Welcome. I'm Robin. I'm an iOS lead at Shopify, and my talk tonight is called "Unleashing the Power of Nil." It's hopefully it'll make a bit more sense as we go through this, but I think we've got a couple cool topics in here. So, first up, this is a view. Rather, it's one view made up out of three subviews. If we wanted to create this view in Swift, we've got a couple options. You could have a horizontal stack view within a vertical stack view, or we can make three individual views and lay them out with some layout constraints. I'm not even going to bother showing you that code because it's way more gross than even this. And this is tolerable for a few views, but I wouldn't want to use it for anything more complex. I would not want to maintain the auto layout code that's required to make something like this. What we want is a way of succinctly describing how to assemble our views. Something like blue view beside red view, above yellow view. Or maybe if you don't like that, we can do this. Blue view beside red view above yellow view. Before we look at the implementation for this, I want to say that this idea comes from Daniel Steinberg's amazing talk on combinators. I encourage you to all watch this. It's really, really good. So he says, a combinator is a higher order function that uses only function application and earlier defined combinators to define a result from its arguments. And what the hell does that mean in our context? What it means is that we can combine the end results of our operations using only previous applications of combinators. In this case, functions that operate on a UI view and return a new UI view. So a couple quick functions here. Extension on a UI view, beside and above, take a UI view and return a UI view. And this is done in an extension on UI view. So a basic implementation of the beside function looks like this. It's defined in an extension on UI view. So if you're new to Swift, not an iOS developer, an extension is a way to add functionality to existing types. So here, we've just made a stack view, added ourself and another view as the range subviews, set the axis, fill equally, and return that stack view. And the implementation of the above function is pretty much exactly the same, except we change the axis to vertical. If you're feeling fancy, you could have the functions just pass the axis into another function. So now we can create our views and apply the beside combinator. Easy. But what if the second view is optional? So we have this function make optional view. Now red view is optional. We can't call this function, right? So we'll have to just quickly update we'll have to do the optional binding at the call site. So, if red view isn't nil, we can do beside. And if it is nil, then we'll just return blue view. Or we can make the other view argument an optional UI view and encapsulate that logic inside the combinator. But what happens if we make the optional view first? Here, red view is optional again, but we're doing the optional view beside the non-optional view. That won't build, right? We need a question mark in there, and then it just evaluates to nil. We have to do what we did earlier, put the optional binding at the call site, and because the value of red view isn't UI view, it's an optional view that might evaluate to nil, we can't encapsulate the optional binding inside the combinator, right? Right? But wait a second. What exactly is nil? In languages that don't support nil, or optionals, nil is the absence of a value. So any old school C programmers, writer, what happens if you dereference a null pointer? Kaboom. Objective-C programmers, what happens if you send a message to nil? Nothing. So let's look at how optionals are implemented in Swift. In Swift, optionals are just implemented as a generic enum with two cases. Either you have none or you have some of a given type. In other words, nil is syntactic sugar for .none. These four statements equate to the exact same thing. Nil is no longer simply the absence of a value, it's a case in an enum. So earlier we extended UI view. Let's extend optional. And optional actually already has two methods defined on it, map and flat map. So here's how you use map, for example. It's great for saving boilerplate optional binding. And outputs the result of a given closure. If the optional instance is nil, it returns nil. So if you've never used this, it's really nice. It takes a bit of time to get used to, but it saves you a lot of typing. So Swift 4 added the concept of conditional conformance. This is just a fancy way of saying that you can define an extension to a generic type, like array, that only applies to specific concrete types. So the sum function wouldn't make sense on an array of strings, right? What would make sense to add up an array of strings? That makes absolutely no sense. But remember how optional is an enum that is generic over a wrap type? We can add conditional conformance to optional where the wrap type is UI view. So now we can encapsulate the optional binding logic such that when the first view is nil, we would just return the other view. So looking at this code, extending optional where the wrap type is UI view, and then put that we have a guardlet. So if self is nil, then just return the other view. But what if both views are optional? We simply update our function and return an empty UI stack view or even an empty UI view if we wanted to. I like to also set is hidden equals true to remove it from the rendering tree. And now we can happily apply our adjacency combinators to optional values without having to litter our code with bindings. So both of these views are optional. I can call red view beside blue view, and everything compiles happily. And remember that crazy view from the start of the talk? This is all the code you need to draw it. And I have a Swift playground if anyone wants to see that. It works pretty nicely. So thank you very much. Anyone have any questions about nils, combinators, or conditional conformances? Yes.
First of all, that's really cool. I've never seen that before. I was wondering if you could extend that concept to instead of like putting the two views in a stack view together, if the first view is already a stack view, add the third view as the arranged subview of that stack view.
Yeah, I mean, so the question is, if the first view, could you have the first view as an array is a UI stack view, and then insert it inside the? Yeah, I mean, you could define the extension on UI stack view, and then if you wanted to have some magic where it would insert it, yeah. Yeah. Anyone else? Ro. I haven't tried it. I mean, this exists and is in use at Shopify in in our common libraries. So I do use this for reusing and combining views from other views. But yeah, I need to look more into Swift UI for that.
Cool.
Yeah. Anyone else? Oh. Anyone speaking into the cube? Oh, Paige. Yeah, so the implementation that I gave is extremely simple. So if we look at this function beside here, the implementation that we have at work has like 5 other optional arguments, like space, like distribution, spacing, a whole bunch of other stuff. So you can really configure it to look exactly how you want. Yeah. Anyone else? No, thank you very much. Well, you're up.